Hi everybody, welcome to Schaefer Machine. Today we got a special one for you. On the bench behind me we got a cylinder head. You guys have seen new cylinder heads before. If you pay attention to our Facebook page, we deal with a lot of these. This is a brand new farmall casting, but this one's a little bit different. A few of you probably already figured it out by looking at the chamber and maybe even the physical size of this thing. But this one's really special because this is brand new. This has never been available before. Now we're really excited to be able to have a bunch of them here to start figuring out how to make them better and sell to you guys to make your tractors run better. If you already guessed it, this is a 350 LP head. Okay, not the M through 450. This one fits the H through 350. This is brand new casting. No more calling junkyards, searching for these things. You just can't find them. And if you do find them, they're cracked, they're worn out, they're junk. So finally, the answer is here. Modeled exactly after the 350 LP head that was made by Farmall in the 50s. We got a good supply of them. We can sell you a brand new casting now. No more hunting around. First one I've unboxed. We're going to measure everything. We're going to see what fix if we can. Granted, these are just like the 450 head. These are not built for performance one bit. They're capable of bolting on a stock tractor and making more power, but we've come up with a couple ways to make the 450 head work a lot better than that. So we're going to do the same thing with these. We're going to take you along with us on some of our measurements, and then we'll get to finishing machining these things. As a casting with a really rough valve job that's not to the guide, I mean, they're not done, okay? They absolutely, all these heads that you buy aftermarket are not ready to run. They have to be machined. So we're going to show you some of the processes and the steps we go through here, and before we put them on the market, ready to bolt on for sale to you. All right, we dug our fixture out from under the bench. Had to do some cleanup on that. We haven't used it in a while. That was one of the first Fusion programs we ever ran. We used that to put in the RMC machine, put it on the rotator, and we can put all of our fixture plates and a vise or whatever we need on the rotator, the RMC with that. The RMC has a 12-inch riser in it to get over top of the blocks, so we don't have clearance issues with top of the blocks. However, we do have a problem getting tools down to the table. So for the most part, doing vise work, we use this fixture. I also modified the fixture to put H and M heads on it using the rocker bolt holes to bolt them down. So we got the fixture out, we got it trammed into the machine. We got the H or the new 350 LP head bolted down to it. And then we checked it for tram. We used the head bolt holes with the probe to do that. It was actually really close. Just had to bump it around a little bit on the bolts and got it within a couple thousandths end to end across a 17-inch head bolt pattern. So that's pretty good. We then dial indicated our zero to our rotation on the fixture, and then put the dial indicator on the head, and it was within a half thousandths across the face of the head. So that means the top of the head and the bottom of the head are parallel. So that's pretty good. We then use the probe on the machine to map out the head bolt pattern, give me X and Y coordinates for every head bolt. I use that data just to compare it against other heads I've checked and our head gaskets that we have made and our deck plates when we completely re-put the head gasket or our head stud pattern back in the block. So after that, we rolled the fixture up to 7 degrees, which is, I believe, the angle that they're supposed to, the valve angle that these heads are supposed to have. We put a pilot in the guide just for easy to probe, and then we can run an indicator up and down the pilot in the guide to map out the valve angles, what they're actually at. We had anywhere from 6.4 degrees to 7.4 degrees. And again, that's with we can use the DRO on the CNC machine to tell us exactly what we got when we zero our indicator. So a little bit off on the valve angles from cylinder to cylinder. It's not really impressive, but we've been dealing with that with the 450 heads for quite a while, so nothing new here. So after we map out our guide location, I just drew a quick sketch on Fusion here. Started with the one on the left, the number 1 exhaust guide, and we just put a point on every guide location using our X coordinates from mapping them out. Technically, Y should all be in a line, and actually they were within 4 or 5 thousandths. The fact that we were probing on a pilot that is quite a bit above the deck surface, I think that's pretty good, actually. I kind of figured a full degree split would give me problems with that, but it's not as bad as I thought it would be. So we're just going to run our program on the 0 line on Y, and then use our probe locations for valve spacing on X. After I did that, I drew a circle with the valve size. I drew a circle with the amount of clearance I want to cut for airflow around our chambers to unshroud our valves. After that, we just extruded a body. The main reason for that is it's easy just to tell Fusion to cut a body instead of just a sketch line. But also I made it the thickness from our valve seat to our chamber top. Now granted, on the actual head, that's going to be on an angle, but I just drew it as our maximum, so we start cutting above the chamber, or above the deck height, and then cut down to the valve seat. And we're just going to do a simple boring operation with a 1/4-inch ball nose end mill to do our chamber, or valve unshrouding, and cut our chambers. It's just going to do a circle representing 150 thousandths gap around our exhaust valve currently, and then a bigger one around the intake, obviously. And it's just going to cut a bunch of air and cut the chamber out wherever it needs more room. And it's just going to run through all the cylinders like that in one single program from one single setup. All I got to do is zero my guide to the left, X and Y zero there. My Z zero is the top of the seat. I set the head to 7 degrees, tram it into the machine, and run the program, and this is going to be all automated from now on. Be pretty slick. All right, why I have the head set up like this, rough cut the valve job with our 3D cutting tool. I do a 5-angle valve job on the intake, and I do a 3-angle on the exhaust. The main reason I started doing that is the 450 has a lot of meat, and I need to cut the throat where the throat percentage on this is already about 90% with the valves that are the original size. So I don't have to cut near as much on these, and might have to probably end up get a bigger valve so I can actually finish the seats the way I want. We can make them work for now, but when I get probably a 50 thousandths bigger valve for the intake, that way I can cut my bottom angles a little bit better and get the throat percentage the way I want it, centered over, make it concentric to the guide. We'll use the CNC machine on our 3D cutter, obviously zero it over the guide pilot, just manually handle jog the machine down until we get the seat the way we want it. I'll zero it, and then I can run through all the exhausts and cut it to the exact same depth. Then I'll do the same on the first intake, get the seat the way I want it, get the valve height the way I want it, zero it, and then run it through the other three. So it should be a pretty quick way to rough in the valve jobs. We're still going to finish it with a stone on the grinding bench, but this should get us most of the way there. All right, the last thing I'm going to do is surface the head. If you saw the head in the fixture sticks above the deck surface, so I can't run the mill straight across like it's normally done on a blocker head. This surfacing head in a CNC machine, and our CNC machine has no tilt built into it, so it cuts flat on this side or this side. I mean, it's dialed into within a tenth or two. It's very, very accurate and leaves a completely flat surface. There's no dish in the deck like on a standard milling machine with tilt built into it. The surface is absolutely flat and clean. MLS gaskets have no issue with it, but it does have a crosshatch looking pattern to it. However, when we bring it in from the side like this, it's probably going to leave a line where it drives in and arcs and has another line where it drives out. You can't feel it. It just has a tool path look to it. I'd love somebody to put a profilometer on it and actually see what we have there, but I know you guys want it to look perfectly shiny and flat, so I'm going to work on this program and see if I can get it to arc better and not leave a straight line. And if not, I'm just going to either modify the fixture or we're going to keep surfacing them on the old machine for you guys. All right, let's get to it. I'll show you the machine cutting, valve unshrouding, do our valve job, and we'll surface the heads. All right, we're at a pretty good stopping point for today. We got quite a bit done. We got the brand new cylinder heads all probed out. We got the programs wrote for the valve job, for the chamber clearancing around our valve unshrouding, and messed around a little bit with a clearancing program to see if we could do it on this fixture, but I'm going to mess around with a little bit more, but looking like I'll still have to go out and put it on the old machine to get a nice flat surface. If I can get the arc just right to come inside here, it'll be I'll use it, but if not, we'll just run it on the old machine like we do now. Just kind of experimenting with that. This casting's a lot better than the 450 LP head in a lot of ways. The chamber centering over where it's supposed to be is much better. The valve unshrouding on the 450 takes a ton on one side and doesn't even hit on the other. This one's a lot more consistent. If you can see my, that's all it takes to get 150 thousandths clearance around our intake valve, which we will check on the flow bench. A lot of V8 racing guys say 100 thousandths to 125 thousandths is enough, but they're working with a wedge style chamber that the valve actually gets out of, where we're completely buried in the chamber and don't even come out of it. So I like to see 150. I'm gonna play with it on the flow bench, and I'll probably cut one at 200 as well and see if I pick up on the flow bench. One thing you got to remember about the farm-alls as well is the cylinder is actually kind of in this area. The valves are partly over the deck, which is obviously not ideal, but it's what we got to deal with. So anything that we can get past this chamber wall is then actually going to crash into the deck. So when I flow these heads, my test adapter mimics that, does the same as it is on the actual cylinder. So trying to make these things work in the real world, not just on not bench racing here. But overall, pretty happy. The guide location front to back of the engine is pretty decent. The bolt hole location is really good. The center one with the dowel is a touch off, but I think we'll be fine. That's compared to other heads and a head gasket. The only thing that I'm not really impressed with is the valve angle, the guides themselves. There's a degree of split. I mean, I had anywhere from 6.4 degrees to 7.4 degrees. The average, I always figured they're a 7-degree head is what they were meant to be. So I'm a little bit disappointed in that. It's something I've worked around before, and we'll continue to do that. The throat percentage, the size of the valve job, stuff like that is closer on these. I don't have to take near as much meat out, but they also still just do a one angle, really bad job that is not, I mean, it's not ready to run at all. It's not centered over the guide. So you have to cut them fairly deep, and I'll wind up probably making a little bit bigger valve for these two so I can clean up the valve job better. Same thing I do with the 450 head. We got them roughed in with the cutter. I always grind afterwards just to double check everything. So we'll still got to grind the seats on these, on this one, and I still got to flip it over, check push rod clearance, and get my valve spring setup all done. So we got a little bit of work yet to do to it, but we made a huge bit of progress to getting these things out the door. Really excited that we have them in stock, and gonna be able to get them out to you guys here real soon. Thanks for watching Schaefer Machine.